Okay, the last chapter, or last section of this chapter deals with groups and periods. Now, this is going to involve how the periodic table is defined and laid out. And so we're going to look at the vertical columns of the elements, and we're going to look at the horizontal rows of the elements. So let's take a look at our periodic table. And as you can see on this particular chart, we have numbers for all the columns, and we have all numbers for all the rows. Okay, now your chart may not have all this information, so when you get a chance, you might want to go ahead and get all these numbers placed in now, because we are going to talk about at this point, and all these numbers over here. So if you want to pause the video right now and you get that done, that's fine. Otherwise, do it after I'm done. But the specific ways of identifying where an element is in relation to two things. One, what number column is it found in? Now you'll notice that there's two sets of numbers. One is in what we call Arabic numbers, 1, 2, 3, 4, 5, 6, 7, those are all Arabic numbers. And the Roman numerals, 1A, 2A, 3B, 4B, blah, 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 3A, 4A, 5A, blah, 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 all the way up to 8A. There's B's here we're going to ignore because they don't have the predictive power that the A columns have. So we're going to ignore the B's, but we're going to use the A's, which we call main group elements. Because there's a very predictive power, like I said, we can predict charges, we can predict electron configurations based upon these things, the stuff that we're going to be dealing with later on. But right now, if I were to ask you to name a column, give me the number of the column of an element, say like for potassium here. Well, potassium has two numbers above the column that we need to have the information for, and that is the Arabic 1 and the Roman numeral 1, capital A, 1A. If I'm looking at iridium here, element number 77, you take a look at this is column 9. Column 9 has a B column with it, 8B, which we are not going to deal with. So if I ask you for the column number or numbers that you have for iridium, you just simply say it is found in column 9, and so on. Those are called groups or families. Okay? If I ask you what group is it found in, you say group 1 or group 11 or group 17. Now, the horizontal rows are called periods. And the reason why they're called periods is because there are certain measurable values that associate with each atom. One, for example, is the radius of the atom. It turns out rather oddly, and you would expect this to be just exactly the opposite, that if we take row 3 right here, sodium is the largest atom of all these atoms right here. And it has to do with strength of protons pulling in electrons. That stuff we'll get into later on. But the farther along you go, the smaller and smaller the atom gets. But then when you go down to the next row, this turns out to be bigger than this sodium right here. So it gets bigger as you go down, but smaller as you go to the right. Okay, so I mean it's easy to compare sizes of atoms on the same row. For example, titanium, you know it's probably going to be bigger than gallium because it lies farther to the left. But if I try to compare the size of titanium with the size of cadmium, it may or may not be the same. So I believe there are some charts that actually have those radius values, but it's not important. We just look at the trend. So the reason why they call it period is because you start in one pattern, and then it starts all over again with the same pattern, and it starts all over again with the same pattern, just like a period in a football game or a basketball game. Like you set it for 8 minutes or 12 minutes, and then when it's over, you reset it and start again for another 8 minutes or 12 minutes. Same thing here. So these are periods. Okay? Now, next, we have nicknames. These elements have been known for some time. The guy who came up with this periodic table, his name was Dmitry Mendeleev. In fact, we have an element named after Mendeleev. Mendeleev. There, element number 101, MD. It's named after the guy who developed the first periodic table. He found these consistencies, so he's the one who developed the patterns here. But the names of the columns became well known even before he discovered these things, because there are certain properties, chemical properties particularly, that these elements in the same column eventually had. Now, they didn't know they were elements in the same column. It just kind of turned out that way. They saw a pattern, and the pattern existed because they were all in the same column. It turns out that all these elements here have somewhat of a tendency to react the same way, especially if you're dealing with nonmetals here and metalloids here. They'll act the same, but they'll act a little bit differently with the metals, but that's not important. The fact is, the same column can experience the same type of chemical reaction. So we have a nickname for it because they've been known for a long time. The nickname for the first column here is called the alkali metals. Now, alkali is a word that means base, which is the opposite of acid. If you were to throw, it's actually kind of cool, if you were to throw a piece of sodium into water, you would see it explode. In fact, I would suggest you go to YouTube and type in sodium thrown in water. And it's pretty spectacular stuff. All right, so, but the resulting solution after the reaction is completed, the violence is done, and the sodium is completely used up in that reaction with water, is what we call a basic solution, where the pH for that is greater than 7. That's called an alkali solution, or alkali solution. So these are called the alkali metals. Now, hydrogen is not a metal. So we don't technically call hydrogen an alkali metal, because when it reacts with water, it just kind of sits there. Doesn't react. In fact, some people would argue that the hydrogen actually belongs over here, which we'll talk about in just a little bit, and in a later chapter about how electrons work and all that. The second column does kind of the same thing, only not as violently. You have to have really hot water in order for it to do that. But these are called alkaline earth metals, and they're called earth metals because a lot of these elements are found not pure form, because if they're pure form, they blow up in a humid situation. But they are found combined with other ions to create a multiple number of compounds that contain these. Now, calcium is really important to us because our teeth and our bones are made up of salts that contain calcium in them. But all of these are pretty dramatically important elements. Magnesium is found in plants. It helps along with beryllium right above it to give it the green color for the chlorophyll, the chloroplasts. So alkali metals, alkaline earth metals. Over here on the far right-hand side, these have been really known. Fluorine, chlorine, bromine, iodine, acetine are called halogens. Halogens. And halogens is a Greek word that means salt maker. When these things reacted with the metals over here, they created all kinds of salt. Obviously, we know about what happens when chlorine reacts with sodium. You get table salt, sodium chloride. But it's a pretty violent explosion. You don't want to be around when sodium and chlorine get together. That's like when you have Thanksgiving dinner and your loud conservative uncle starts butting heads with the loud liberal aunt, and they can't stop. And next thing you know, you have this violent thing going on between the two of them across the dinner table, and everybody's looking down going, please go away, please go away, please go away. It's kind of what's going on with fluorine and sodium. The last one, and this is the fourth type of element that we were talking about in the last lesson, that is these elements right here in group 18 or 8A. These are known as the noble gases. Now they're called noble gases for two reasons. One, they're gases, duh. And two, when you hear the word noble, you hear the word nobility in there. Nobility is like the king and queen or duke or duchess. They don't work, they just exist with money somehow that they get. You know, the duke, duchess, I guess, get money from the king and queen. The king and queen get money from their loyal subjects through taxes or whatever, so they can call themselves king and queen. I never have figured that one out. But anyway, because they are not going to work, we call them noble. In this case, they don't work because they don't react with anything. Now, you can push these two right here, krypton and xenon. If we add a lot of heat and make something react with a very reactive substance like fluorine and chlorine, fluorine and chlorine are extremely reactive, just like sodium and potassium, very reactive. But they will react with this to create a gas that, but it's almost, almost impossible to keep it stable. It'll almost turn around and decompose as soon as you make it. So, what's the point? So, that's the layout. Now, these two columns down here, I want to talk about these two columns right here. This area right here is called transition metals. This area right here is called intertransition metals. And the reason why they're called intertransition metals is because all 14, or in this case 15 of the elements, I think your chart may have something else a little bit different, but the whole thing wedges right in here in this space that I have. 56 for barium, 72 for hafnium, and lanthanum through lutetium, 57 through 71, wedged right in there. So they aren't separate down here, they're actually part of this, but they do that because you can't have paper wide enough for a periodic table, so they stuff them down there. So look, same thing here with the actinium through the lawrencium, that goes right here, that wedge is right there. So this is technically in the 6th row, this is technically in the 7th row. Okay? So, let's take a look at some practice problems. Okay, it says give the group number, period number, and nickname of the group value as founded. Now, one thing I have not talked about is it's funny, thallium. Here, go to the periodic table, and yeah, the answer to that's not right, so we're going to have to fix that. But well, let's get back to this. Here's thallium right here. The group numbers are 13 and 3A. You have to put them both down there. The period number is 6. The name of this column, well, we didn't give nicknames to all of these columns. We just did for the first two and last two. But the others do indeed have nicknames. They are simply called the family of the element at the top. So in the case of thallium, thallium is found in the column that begins with boron, so this is considered the boron family. Okay? Now, I think I might have the wrong answer up here, so I'm going to have to fix this up, and I'll make sure when you get a copy of this that will be taken care of. Yeah, I'm off by 1. So, this is thallium here, so this is group 13 and Roman numeral 3A. Period 6 is correct, and instead of the zinc family, this is the boron family. So I'll make sure to get that fixed for you. Alright? So, group number, or numbers, 2 numbers, because it's got an A column with it, 13 and 3A, Roman numeral 3A, period number is 6, and the nickname of the group that thallium is found in is the boron family. Okay, so here's your practice problems here. Find the group numbers, period, number, and the name of the columns that these elements are found in.